Okay, the nice part about today is it's really like review from stuff you learned back in Algebra 2. But we are doing a little bit, we're getting into matrices, so kind of brushing up what you learned about matrices, how to do all those operations, so that we can kind of move on with some other things with it this week. So we're actually starting at 8.3. So make sure this is I think that's the first notes packet. So hopefully, again, like this looks familiar, but every year I have to brush up on like how you count a matrix, like rows versus columns. So remember, like the horizontal lines is the amount of rows, the vertical is the columns, and then this our book uses the word order. Some other books call it the dimensions. So when it asks you the order, or when you're asked the order, that's what it's asking for. And mostly we want to remember that it goes rows and then columns. So how many lines horizontally do we have? How many lines vertically do we have of our numbers? Now this one is not a great example because it's a 2 by 2, so it doesn't like distinguish which is which. You will also notice that like our book, and a very common notation for matrices is identifying the individual elements by row column numbers. So like this would be first row, first column would be element 1, 1. Or like first row, second column would be element 1, 2. Just so you understand what those notations are meaning. You won't see those very often, but if you ever do run into that again, you'll know what that means. So identifying the order again goes rows by columns. So rows is our number in this direction. We have 1, 2 of them. Columns is this direction. We have 1, 2, 3 of this. So we would have a 2 by 3 matrix. And then again, identify if we're calling this matrix B and it's I by J, identify what the element is in 1, 3. Remember that is the same way that we do our order. So it would be row 1, which would be here. Column 3. So row 1, column 3, B 1, 3 would be pi. Similarly, 2, 1 would be the second row, first column. So 2, 1 would be negative 3. Questions? Just 1 second.
Okay. Equal matrices just means that they are the same order. So like on our last page was a 2 by 3, another 2 by 3 could be equal to it if all of the corresponding elements are also equal. So how do we use this? Well, a lot of times they'll say that we have equal matrices and all we have to then do is match up the corresponding elements and say that they're equal to each other. So if it says find the value of the variables such that the matrices in each exercise are equal, that means your element 1, 1 would be equal to your element 1, 1, or I just kind of like to talk where they are. Top left would equal your top left. So X would equal 4. Top right would equal top right. So 2y would equal 12, or y would equal 6. And in this one, the only other variable we have is bottom left equal elements. Okay, questions? Adding and subtracting matrices, again, corresponding elements. So as we do this, your top left element gets added to your top left element. Your answer will be the same size matrix, and that would give us our top left element. So this would be 0 plus -2 or -2. And we do that for each of the elements along our matrix here. I'm gonna give myself a little bit more room. So like 5 plus 3 gives us that element 1, 2 of 8, and 3 and 5. again, 8 here. Okay, same thing for that next row, -2 plus 7, 6 plus -6, and -8 plus 6. And our answer should be the same size as our originals. Now, the only thing that you will notice here is, okay, if I'm supposed to be adding or subtracting corresponding elements, if they're not the same size, you can't do it. So almost every operation that you're ever asked to do will be followed with a question or the statement, if possible. And you can always say not possible. If they were to hand you like a 2x3 and then like a 2x2, well, we don't have corresponding elements for everything, so it's not possible to even add them together. The only thing you have to be careful of is when subtracting. One of two ways you can do this is just show each one or distribute that negative through everything, change it into a plus and go through and change the sign on everything. That might be a good strategy for you. So what I'm basically doing is distributing the negative to every term inside of here and changing this into a plus. So then if I go do that, we tend to make less mistakes when we are thinking addition versus subtraction. It is the same thing. I just distributed that negative through. So my answer again will be a 3x2, adding corresponding elements. So now 5 plus 4 would be 9. 4 plus -8 would be -4. -3 plus -6 would be -9. 7 plus 0 is 7. 0 plus 5 is 5. And 1 plus -3 is -2. And again, when we change it to a plus by distributing that negative through, just like if it were like a parentheses or something after that, we tend to make less mistakes. So I would suggest that. Distribute the negative through and make it addition instead. Questions on the subtracting? Scalar multiplication, very similar idea of what I just did with the subtraction is you're just distributing it. And so if we have a number sitting outside your matrix, that means that it is supposed to be multiplying every element inside of your matrix. Can look a couple different ways. This can represent a matrix, that is matrix A, or this is matrix A. And all that means is scalar multiplication is that you've got this number. Notice there won't be an operation. It's very similar to like a variable, just squished up next to it. That just means take every element and multiply. This is without like simplifying it. Our ultimate result will be the same size as it started out. And we would go ahead and do that. So 4 times 2 is 8, 4 times 5 is 20, 4 times -3 is -12, and 4 times 0 is 0. And that would be the result of 4 times A. Okay, so we can kind of put a couple of these operations together. A scalar multiplication, a couple scalar multiplications, and addition. I would do the scalar multiplication first and then add corresponding elements as I do this. So let's go ahead and try a couple of these. -6b says my scalar multiplication is -6 times the matrix that they give me, that is B. Oops, -1, -2, 8, and 5. Means I'm taking that -6 and distributing it to all elements within. And our result would be, let's see, 6, 12, -48, and -30. Similarly, on this next one, kind of combines our multiplication and addition here, is I would multiply my scalar multiple through each of those and then combine my corresponding terms from A to B. So when I go ahead and multiply everything by 3, we get -12, 3, 9, 0. -2, -4, 16, and 10. Double check all my numbers so that I don't make a mistake there. And then we just add our corresponding elements. -12 plus -2 would be -14. 3 plus -4 would be -1. 9 plus 16 would be 25. And 0 plus 10 is 10. All making sense so far? Okay. Matrix equations. The one thing, the major change between what you saw on the last page, which is just putting some things together in a matrix equation, is in an equation we are going to solve for this matrix X. And so at the end, we're going to have X equals. And there are a couple things that we want to be aware of as we do this in our matrix equations. First of all, I would move this around to have X by itself before I ever start putting matrices in there. Remember, A represents this and B represents this matrix here. If I were to get X by itself, first of all, I would subtract matrix A. And here is the difference. Here is that instead of dividing when we are dealing with matrices, I would multiply by a reciprocal. It's going to be easier than trying to like divide a matrix. So dividing by 3 is the same thing as multiplying by 1/3. And so I'm going to take both sides and multiply by 1/3. And ultimately we have X equals 1/3 times whatever we get when we take B minus A. And I'll end up just having a scalar multiple of 1/3 out front. So let's go ahead and do this. First of all, B minus A, again, I would consider doing, let's see, B is -10, 1, -9, and 17, minus A, which is 2, -8, 0, and 4. I always will recommend distributing a negative through and adding corresponding parts. So I'm going to distribute this negative through, change this to plus, and change the sign on all terms. And now I can just combine, and we will make way less mistakes doing it that way. So let's see, -10 plus -2 is -12, 1 plus 8 is 9, -9 plus 0 is -9, 17 plus -4 would be 13. Okay, and now it's the distributing the 1/3, which is the dividing by 3 part of it. So distributing 1/3, again, kind of thinking about dividing by 3 would be, let's see, -4, 3, -3. And then you can have fractions in here, like 13/3 would be 1/3 times 13. You can leave it as a improper or a mixed number, but let's leave it exact. Questions? So that's your matrix equations. Ultimately, when it says solve the matrix equation, you're trying to get X by itself. The only difference I would do on that one is instead of dividing by 3, multiply by its reciprocal. All right, and then matrix multiplication. This is the first time that like it's not super intuitive. I think adding and subtracting, if I just handed you those and asked you to add or subtract, we would probably guess at how to do that without me talking about it. But it's the matrix multiplication that takes a little bit of time. First of all, when we are doing this, there are some things that will stop us. They do not have to be the same size. This is your key right here, is that your inside order numbers need to match. So as I set them side by side, an order that we multiply does matter. I would look at their orders as an M by N and then an N by P, and it is very important that your inside 2 numbers match because of how multiplication works. And then your outside 2 numbers with the orders ends up being what size your answer will be. So as long as these inside ones match, your outside numbers give you the size or order of your answer. This is why the inside numbers need to match, because when we do multiplication, it is row by column. Again, same thing that is like our dimensions. It's always rows by columns. And so you take the first row times the first column, and that gives you your element in the first row, first column. And we do first times first plus second times second, and we would follow that for however many elements we would have in that first row, first column, and add those resulting values. Okay, so what you guys are looking at is like a generic with letters A, B, C, D, E, F, G, H. And you can see how we get each of these again. If I were to take my first row, second column, I would get my first row, second column value. Okay. And this one just takes practice, and it takes slowing down and forcing yourself to like only look at the correct elements. So let's look at some matrix multiplication. Again, remember, it's going to say where possible because not all of these will be eligible to multiply. So the first thing I look at is what are the dimensions of A and B? So A is a 2 by 2. B is a 2 by 2. To be able to multiply, your inside two numbers must match. They do, so it's possible. And our answer of AB will come from those last two numbers and will be also a 2 by 2 in this particular example. So A times B, again, order matters. We start with first row, first column. We match up our first element to first element, second element to second element. So 1 times 4 plus 3 times 1. And then we do the same thing. First row, second column, 1 times 6 plus 3 times 0. And then we move to that second row and we repeat the process. Go back to your first column. 2 times 5, 2 and 5 times 4 and 1. First element times first element, 2 times 4 plus second element times second element, 5 times 1. And same thing, second row, second column, 2 times 6 would be first times first, 5 times 0 would be second times second, and we clean it up. How are we doing? Following all those numbers? Okay. So as I clean this up, I just need to, let's see, 4 plus 3 is 7, 6 plus 0 is 6, 8 plus 5 is 13, I think, and 2 plus 12 plus 0 is 12, and that would be our answer matrix, 2 by 2. Yeah? Good? Okay. So I want to prove to you real quick here with the 2 by 2, because these are easier to do, is that the order does matter and will change our answer as we do this. Now, it's still a 2 by 2. So if I check my possibility of being able to do this, our inside numbers still match even if I flip B and A, and our answer is still a 2 by 2, right? But the order of these two matrices will flip. Okay, so you guys try this one. right. Am I matching anyone? Yes? Nice. Mental math's always a little shaky on a Monday, right? And by Monday, I mean day, every day. Okay, any questions on the multiplication? Now, on these first two, again, I pointed out that it when possible, and we talked through that these actually worked, but a 2 by 2 and a 2 by 2, obviously order did not matter on being able to do this. So let's look at some where it does make a difference. So on this last one, we're going to do AB first. And again, we'll decide if possible. Make sure you slow down and look through that part again. So let's talk about A is easy. I don't really have to think about its dimensions because it's a 2 by 2, right? What are the dimensions of B? Two by 4, yep. So that's where we have to slow down rows by columns. And then we ask ourselves, can we multiply these together? And because the insides match, the answer to that is yes, and which means our answer then is a 2 by 4. Okay, and so now we take our first row times our first column, and we're going to work our way all the way across that matrix. I'm going to do the first row first. You do not, what I'm writing out here, you do not have to write out. This is purely for like notes and such. You can do this part, like kind of clean this up as you're doing those numbers in your head if you want to. If it's helpful to write it all out for you, do that. So that would be my first column. And then I move to my second column for my second number. And then I move to my third column, and sometimes color coding this or like physically covering up other numbers so you can't see them can be helpful. I like the little rectangles as I'm doing it because it forces me to look the correct direction. I remember which way I'm supposed to be multiplying. And then we start over. So now I'm going to go back to that first column again and move down to my second row. So now I'm using that 1 and 3. Move to my second column. So the mental math side of it is not tough. It's really the organization part of it that I think keeping numbers in the right places, making sure that I've multiplied the correct two numbers together to get these. And then just, yes, obviously being cautious with my cleaning up part here. So let's see, this would be 4 plus 0, 8 plus 4, 12 minus 2, 16 plus 12, 1 plus 0, 2 plus 6, 3 minus 3, and 4 plus 18. And there's our resulting 2 by 4 matrix. And just like we saw on the last page, if I were to flip that order, obviously it will impact my answer majorly on this one, because if I ask you to do a B times A, can't do, right? So you shaking your head. Because B is a 2 by 4, and this is the first time we're going to see this, A is a 2 by 2, and as I check, they don't match, right? Which means it is not possible. Because those two inner numbers of our order do not match, can't even multiply them together. Questions for me? All right. we are going to skip that, and you already have your worksheet.